Today we're working on factoring trinomials, and we're going to concentrate in this first video on factoring trinomials that have a equal to 1 when it's like a quadratic equation. Okay, so let's talk about what are those things. So first of all, a trinomial is when you have an expression that has 3 terms. So tri, remember, means 3. So a trinomial is going to have 3 terms to it. And remember, the terms are separated by your plus and minus signs. So a trinomial will have, you know, a number and a variable, and then it's going to have a plus or a minus sign. So it could be either one. And then it's going to have another number and a variable, and then another plus or minus sign. And then it's going to have one other number, variable, or something like that. So this would be a trinomial because it has 1, 2, 3 terms. Okay, so a trinomial has 3 terms. Okay, what we're doing is factoring quadratics. And so remember, a quadratic equation, the standard form is ax squared plus bx plus c, and usually it'll be equal to y. But when we're factoring, you'll just usually see this expression. And so notice that has 3 terms. That's a term, then you have the plus sign, that's a term, then another plus sign, and then you have your last term. So that is a trinomial, okay? What we're practicing in this video is factoring trinomials when the a, the number up front, is a 1, okay? And so the problems that you see today, and you could probably look at our examples and be able to see that, you're going to have just a 1 in front of the thing that's being squared, so it's going to be 1x squared, and then you might have different numbers for b and c. So that's what our problems today are going to look like, okay? So if you see a quadratic that has a 1 up front, and make sure it's in standard form, so it goes highest degree to lowest degree. If it has a 1 up front, you're going to try to factor it the way that we do today. Okay, so then how do you do that? So these were the notes that were in the slide that you just copied down. Okay, so all I've done is I've copied them here, and we're going to go through them. So let's look at our first example here. Let's say that we had to factor that. Well, check to see, is it a trinomial, or is it like one of the problems that you did yesterday with the difference of perfect squares? And remember, those are going to be binomials, so it's going to be 2 terms, okay? So look at how many terms it has. That's a term, that's a term, that's a term. So that means we have 3 terms. So you're going to try to factor it like this, okay? And notice the number that's in front of x squared, it doesn't have 1, and so that technically means that's a 1. So that's these types of problems. The first thing that you want to do with any factoring problem is you want to check to see if it has a GCF. See if there is a greatest common factor in the problem. Do your terms have something in common? So notice they don't have an x in them because the 7 doesn't have an x with it, so they don't have a variable in common. And the numbers, they don't have anything besides 1 that will go into them. So that means that they don't have a GCF. So then, how do you factor one of these? Well, what you're going to actually do is what's called trial and error. And that means you're going to try something, see if it works. And if it does, yay! If not, you have to erase and try again. So that's trial and error. Okay, so to set it up, you're going to start by putting parentheses, so kind of like what you did yesterday. So you're going to put 2 parentheses. Then you're going to go ahead and look at the first term, and you're going to ask yourself, what multiplies to give you the first term? And for these problems, it's going to be a little bit easier, okay? So what multiplies to give you x squared? Well, x times x does. So you can go ahead and put that in. That's going to go in the first spot here, because remember, what we're doing is undoing multiplication. Like when we multiply stuff out, this is what we end up getting. So we're undoing that. And so these 2 should multiply to give you that first term. And notice x times x gives you x squared. Okay, so that's the next step. Then you have to figure out, what are my signs that are going to go in here? Well, that's going to depend on the last sign in your expression. And so notice your last sign in this problem is a plus, okay? And so if the last sign is a plus, what that actually means for your problem is that your signs in these parentheses will be the same. And it's going to either be that they're both pluses or they're going to both be minuses. Well, then how do you know? You look at the middle sign, and that tells you what they're both going to be. So the last sign tells me that they're going to be the same. And then once I figure out that they're the same, I'll look at the middle sign, so that's your middle sign, to know what they're both going to be. So that because that middle sign is a plus, that means that both of my signs are going to be pluses. So I go down here, I put a plus in that one, and I put a plus in that one, okay? Now, if the last sign is a minus, then what that actually means is that my signs are going to be different. So that means you're going to end up putting a plus in one of these, and you're going to be putting a minus in the other, okay? And so look out for that, because that'll tell you what the signs are. So once you figure out the signs, this is where the trial and error part starts, okay? You're going to start by listing out the multiples of the last term. In other words, what multiplies to give you this last number? And you don't even have to look at the sign that's with it, because we're going to deal with that in a moment, okay? So, well, let's write to the side. What multiplies to give me a 7? Well, this one's pretty easy. The only thing that multiplies to give me a 7 is 7 and 1, okay? So, from there, you have to ask yourself this question, okay? It says, then you ask yourself, what numbers multiply to equal the last term? So you've already wrote that down. But they also have to combine to equal the middle term. And that's a question, so that should have a question mark. So let's add a question mark there, okay? So out of all of these multiples, which of these will combine, remember, with these signs? So in this problem, they have to have both plus signs to give you an 8. Well, this one's a really easy one because this is the only possibility. So if this one didn't work, then this would be not factorable. So you would say it's prime. But notice, if I take a positive 7 plus 1, that gives me 8, which is my middle term. And so I know this would be positive 7 plus 1, okay? And then you could check it. So number 1, you can make sure, okay, does positive 7 plus 8 give me this middle term? And yes, it does. Or remember, you can go to the side and multiply it out. So if you needed to check this one, you would just simply multiply this out, and you should end up getting what you started with. So if I take it and multiply it out, it'd be x times x, which is x squared, x times 1, which is a positive 1x, and then I take the 7 times x is positive 7x, and then 7 times 1 gives me 7. And so notice, you can kind of see where all of the reasoning that we just did comes from, because I talked about they have to combine to give you that, and notice that's where that comes from, is because when you multiply it out, these are the numbers that you get that will combine, and that should equal the middle term. And then we just simplify. So the x squared doesn't have anything to combine with. The 1x and the 7x will combine because they're like terms. You end up getting 8x, and then that 7 comes down. And notice, we end up with what we started with. So we know that this is correct. So this would be our answer. Okay, so when you are factoring, you're going to look to see if it's a trinomial. If it is, if it has a 1 up front, then you're just going to follow these steps. Okay, so let's go through a couple more so that you can kind of get used to how this works. And then we'll switch to what happens when a is not equal to 1. Okay, so with this one, first thing, look to see if there's a GCF. Do these terms all have anything in common? And notice they don't have a variable in common because that one's missing the y. And then there's no other number other than 1 that will go into all 3 of these. So there's not really a GCF here. Okay, It has 3 terms to it, so that means it's a trinomial. And then notice the number that's in front of your y squared is 1. So we can do it this way, okay? So we've already looked for the GCF. So the next thing, we're going to try to do it with trial and error. So we put parentheses. Then we list what multiplies to give the first term. So, and like I said, in these problems, it's going to be a little easier because, well, what multiplies to give me y squared? That would be y times y. So we go ahead and put that in the front. Then we look at the signs. So start by looking at your last sign. So our last sign here is a positive. So that means when we look over here, they're going to be the same. And then we have to look at the middle sign to see what they're both going to be. So this means they're the same. So now I'll look at that, and that tells me that they're both going to be positive because it's a positive. So they're both going to be a positive. So we can just put a little reminder up there that they're both positive. Then this is the part where the reasoning starts. So we list the multiples of the last term. So to the side, I'm going to take and look at my last term here, and I'm going to write down what multiplies to give me that. So 8 times 1 will give me 8. 4 times 2. And then I think that's about it. So we're going to look at each one of these, and we're going to ask ourselves this question. Which of those numbers that multiply that equal the last term will combine, remember, with those signs, so that means they're both going to be positive, to give me the middle term. And so my middle term, the term that I'm trying to get, is a 6 here, a positive 6. So which of these, when I combine them, both of them being positive, will give me a 6? So like 8 plus 1 gives me 9, so that's not going to work. 4 plus 2, that gives me 6. So this is the one that works. So because the signs are the same, it doesn't really matter where you put the 4 and the 2. If the signs were different, it would matter. But notice that'll work out. And then you could go to the side, just like I did here, and multiply it out and check it. So you would take y times y, which is y squared, y times 2, 2y, and then 4 times y, 4y, 4 times 2 is 8, and then we combine them. So we got y squared, that gives me 6y, which is why we had to check to make sure it equals that, and then we get the 8. So notice that works out. So this would be the factored form of that, okay? So let's keep going. So the next one, it's a trinomial. It's got a 1 up front, so we're going to be doing it like the other problems. Check for a GCF. Do they have anything in common? And notice they don't have a variable or a number in common, so we can move past that. Then it's a trinomial, so we're going to do the trial and error. So go ahead and put your 2 parentheses. Let's go ahead and look what multiplies to give you the first term. So what times what gives me b squared, and that would be b times b. Then look at your signs. So start by looking at the last sign. So in this problem, our last sign is a negative. So that means the signs in my parentheses are going to be different. So that means one of them is going to have a plus sign and the other one's going to have a minus. And now for these problems in particular, it doesn't really matter where you put the plus and minus signs, but when we get to the problems in the next video, it will matter. So just pay attention to that, okay? But for these problems, because of the way they work, they're a little easier, so you can go ahead and put the signs in. So we have to keep this in mind that they're going to be different when we do this last part, okay? So the last part is where you list out what multiplies to give you the last term, and remember you can ignore the sign because we're going to take care of that here. So what multiplies to give me 3? Well, the only thing that really multiplies to give me 3 is 3 times 1. So ask yourself this question. What numbers multiply the equal to last term, so we've already listed those out, and combine, meaning adding or subtracting, to equal the middle term, okay? So here's where you have to keep this in mind. One of these numbers has to have a positive with it, and the other has to have a negative. So you have to think about, okay, how can I combine these numbers, because these are the only numbers we have, that would give me, our goal is to get a negative 2 out of it, okay? And so you could go to the side and think about it, okay, if I take positive 3 minus 1, what does that give me? And that gives me a positive 2, so that doesn't work. So then what if I switch the signs? So what if I put the negative with the 3? So negative 3 plus 1, does that give me negative 2? And yes, it does. So that's what I want to do here. Sorry, I just scratched out my negative 2, okay, is I want to put the negative with the 3, okay? So notice that I have to pay attention to where I put my numbers now. So I want the 3 with the negative. So the negative's there, so I'm going to put the 3 here, and then the 1 would have to go there. If I flip-flop my signs, like if I put the negative in this one, then the negative 3 would be in this one. So notice these factors could be flip-flopped, and notice that's fine because you're multiplying them. And so this will be the same if I have the b minus 3 up front and the b plus 1 behind. So they would actually end up being the same thing. Okay, so there we go. And then you could check it, because remember, you can go to the side and multiply it out like I did here, so don't forget about that. But if I take a positive 1 minus 3, I end up getting negative 2. So I know that's my answer. All right, let's do another one. So this one, got a trinomial. There's a 1 up front, so I'm going to try the trial and error. Make sure that you look for a GCF first. So is there anything in common? This one doesn't have anything in common, so we can just move past that. Go ahead and put my 2 parentheses. What multiplies to give the first term? So what times what gives me x squared? That would be x times x. Then we look at our sign. So the last sign in this one is a plus. That tells me they're going to be the same. And then remember, you look at that middle sign to know what they're both going to be. So in this one, they're both going to end up being negatives. So we can go ahead and put our sign in there. Okay. Then you list the multiples of the last term. So what multiplies to me? 6. It'd be 6 and 1, 3 and 2, and then that's it. So now which of these, with those signs, so they're both going to be negative, will combine to equal the middle term? So our goal is to get them to equal negative 5. Well, if both of the signs are the same, well, okay, let's think. Okay, negative 6 minus 1, does that give me negative 5? No, that gives me a negative 7, so that doesn't work. So, okay, what if we take negative 3 minus 2? Does that give me negative 5? If it does, then that's my answer. If not, then this would be what's called prime, because that means it wouldn't factor. Okay, so if something doesn't factor, you would call it prime. Kind of like a prime number doesn't have anything that will multiply or divide into it evenly other than itself in 1. If something doesn't factor, that means it's prime. Okay, so well, let's see. Does negative 3 minus 2 give me negative 5? And yes, it does. So this one does factor. And so because they have the same sign, you could put the 3 here or there, but then the 2 would go in the other one. Okay? And then again, you can multiply this out to check it. But there you go. All right, so let's do 2 more, and then we'll switch gears to what happens when you have something other than 1. Okay? So, same story. It's a trinomial. Check for the GCF. Is there anything in common? And no. There's a 1 up front, so that means you're going to do trial and error. So, you put your 2 parentheses. What times what gives me n squared? That would be n and n. Then you look at the last sign. It's a negative, so that tells me my signs are going to be different. So, there's going to be a plus in one and a minus in the other. So, for these problems, you can go ahead and put the signs in there. And then you list out what multiplies to give you 6. So we kind of just did the 6. We already know 6 times 1, 3 times 2 will give me 6. But notice this time we're trying to get a different middle term. So now we're technically trying to get a positive 1. Okay, so we have to think. And our signs are different. So that means one of these numbers is going to have a plus with it and the other one's going to have a minus. So think through it. If I have like a 6 minus 1, does that give me 1? No. Okay, well, what if I reverse it? What if I put the negative with the 6? So negative 6 plus 1, does that give me 1? No. So that one doesn't work. So if you know it doesn't work, cross it out. So now let's try the 3 and the 2. If I take positive 3 minus 2, does that give me a 1? And yes, it does. So think about, it's a positive 3 minus 2. So the 3 has to go with the positive, and then the 2 has to go with the negative. Okay, and then again, don't forget, you can multiply it out just to check, but then that is the factored form of that. Okay, last one. So this one is a trinomial. You got a 1 up front. It doesn't have, all three terms don't have anything in common, so you don't have a GCF. Well, it's a trinomial, so we can do the trial and error. So I'm going to put my 2 parentheses. What times what gives me x squared? X times x. And then look at your signs. So the last sign is a negative, so that tells me they're going to be different signs. So I'm going to put a plus in one and a minus in the other. And then you're going to start listing out the multiples of 72. So when it's a big number, which they may give you a big number, what you're going to do is just start dividing that number by all the numbers you have. So 72 divided by 1, well, 72 times 1 would give it to you. Then you can take 72 divided by 2, and that gives you 36. So 36 times 2 would give you 72. Okay, keep going. So 72 divided by 3, well, that gives you 24. So 24 times 3 gives you that, and then you can keep going. Not all the numbers will divide evenly into it, but you're going to try to find all the ones you can find. 4 will go into it. 18 times 4 would give you 72. And now you may not necessarily have to list all of the multiples, but I would get a good list written down so that you have a lot to look at, because you're looking for, remember, which of these will combine to give you that middle number, which in this case is a -1. So you can kind of look out for that as you go. But if you haven't found it yet, then you have to keep going, okay? So like 6 will go into it. 12 times 6 gives you 72, and then you just keep going. And if it gives you a decimal, then that's not one that works. 8 times 9 would give it to you. And so let's see out of all of these if any of those work. So keep in mind, you're looking for which ones of these will combine with these signs, so they're different signs, to give you -1. So you can kind of start working through it, kind of like what we reasoned through the other ones. And eventually you'd figure out, okay, we got to get a -1 out of it. So we're looking for ones that are 1 away from each other, essentially. And notice this one is, so let's figure out, okay, which one has to be positive and which one has to be negative. Well, we're looking for a -1. So the bigger number would have to be negative. So think about it. +8 minus 9, does that give me -1? And yes, it does. So the 8 would go with the positive sign. The 9 would go with the negative. And then if you're not sure, remember, you could multiply it out like I did the first 2 examples to check it. And so that's how you factor a trinomial when the number up front, is 1.